Hi guys, so today I'll be recording two more videos right now. One is this red band transshipment model. So this is the case of transshipment. Now there's a major difference between transshipment and transportation. So transportation is where there is a warehouse and you keep a stock in the warehouse. Whereas in case of transshipment, the intermediary nodes. So for example, here 4 and 5 are the intermediary nodes. They don't have any stock, so they just receive the goods from here S1 S2 S3 and give it to D1 and D2. They don't hold any stock, whereas in a transportation problem they will have some internal stock as well. So I just read through this red band case. So here it says that red band produces a tomato plant, tomato product at 3 plants. So because it's a tomato product, there's a like perishability, that's why it's a transshipment. uh, the cost of the producing the product is same at the plant. So here it's that factor is common. So any plant you make, the cost will be the same. A question might also give you a variable about इस plant में बनाया तो इतना cost, दूसरे plant में बनाया तो इतना cost. The product can be shipped directly to the company's two customers, or it can be first shipped to the company's two warehouses and then to the customers. The production capacity at each plant and the demand are shown below. So when we describe the nodes, I'll go through that. So there are basically 3 plants and 2 suppliers, um, and 2 demand points. So 2 warehouses and 2 suppliers that I send it to. Okay. Um, the cost of shipping a ton of the product between each pair of location is listed in the table annexure 2, and a blank means that it cannot ship to that location. We also assume that at most 200 tons of the product can be shipped between any two nodes. This is the common arc capacity. So basically, it says that on any road, the maximum you can send is 200 tons. You can't send more than that. Redband wants to determine the minimum cost shipping schedule, develop a optimization model to ship the tomato uh, product. Okay, so this is the network that we have. Uh, so these are 3 suppliers: S1, S2, S3. T are the transshipment points, and D1 and D2 are the warehouse. The customers. Now customers want 400 and 180, which is 580, and this is 200, 300, and so 600 units can be produced, and uh, 580 can be is the demand. So obviously there's no constraint over there. And because it says T0, we know that it's a transshipment point. Now this is the from node to node. So basically it says that from node. So from node 1 to node 2, so from node 1 to node 2, again, you see here between 1, 2, and 3, the arrows go both ways. So it can go from 1 to 3 or 3 to 1 also. But here from 1 to 4, it can go only from 1 to 4. 4 to 1 is not possible. So 1 to 5, 1 to 2 is 5 rupees per. Uh, so this is the cost of shipping. So it's a cost in thousands of dollars between pair of locations. So here 1 to 2 is 5, 1 to 3 is 3, and so on. So these are the nodes. So what we have to make is basically a list of possible node points and the cost of it. So let me go into the question. So this is the transshipment one. I'll just delete these figures. Right. Now, what we have done over here is basically uh, made a table of all the origin points. So from origin 1, their destination 2, 3, 4, 5, 6, 7 is possible. So I've put all the origin and destination points. Then I put the unit cost of each point. So you can see from here, one from node 1 to node 2 was 5, then 3, then 5, then 5, 20, 20. So I've put that over here. And so for each node, you put this. Now flow is the amount of shipment from one node to another node. So again, this will be in the number of units, and then you multiply it with the unit cost, and this will give you the total cost. So for the total cost, we have this function sum product into flow into units. So flow is basically this column into this column. Now, uh, my first objective was be to minimize this total cost. Keeping in mind the constraint. So here the constraint are that the plant capacity for node 1, 2, and 3 are 200, 300, and 100, which is given over here. So it says that this is the capacity 200, 300, and 100, and the demand constraint is 400 and 180. So because I have to meet these demands, it's equal to, and because this is a capacity constraint, it's less than equal to. And because it's a transshipment point, we have a warehouse. So warehouse does not hold any stock, so it's zero. So whatever is coming in is equal to whatever is going out. So for the first one, let's see. So we have here the formula um, sum if. So what we have done is basically for node 1 we are saying that sum if origin is 1, comma. So uh, I9 is 1. So or if origin is 1, then calculate the flow amount minus destination minus I9 flow. So basically it's saying whatever is coming in minus whatever is going out. So origin point means is going out from there. So whatever is going out minus whatever is coming in, because you remember that there is a two-way point. So it's possible to send 1 to 3 and something can come back from 3 to 1. So we have to take into account that as well. So that's why here what we have done is origin minus destination. So both ways, because here there are some points where it's getting some goods from 2 to 1. So that's the same formula that we had used for everywhere. So instead of I9, it's I10 and I11, which is this 1, 2, and 3. This should be less than the capacity. For the warehouse, what we have done is basically again, uh, here basically again, it's the origin. So whatever is coming into the warehouse minus whatever is going out of the warehouse, that should be equal to 0. So it'll do a sum if of all the points that have an origin of 4. So these points which have an origin of 4 and all points which have a destination of 4. So here, here, and here. Same for 5 and 6. For 6, what we have done, it's again destination and origin. Considering uh, there would be something that might go from one customer to another customer as well, because I think that is also possible. So something might go from 6 to 7 as well. So that's why we have done both destination minus origin. So we have done the opposite here. Whatever is coming in minus whatever is going out. So that's why it's destination minus origin, and here it's origin minus destination. Right now, we also have a common arc capacity, which is 200 in this case. So when I put 200, I've said that in any of these cases, it cannot exceed 200. So I've put a constraint over here that any of these points cannot exceed 200. So now I'll go into solver to go to data solver. My first objective is to minimize the cost. So here, what is my objective? Go here, go to cost, and then do minimization by changing variable cells. So my variable cells over here are these flow cells. Sorry, from here to here. So these are the variables that will be changed. Now constraints are, it's very simple. Once you figure out the most complicated part of this is the formula of destination or origin. Otherwise it's just this variable should be less than equal to, and then constraint is again these. Now click on add, put another constraint that this should be less than equal to this. Sorry, it's not less than equal to, it should be equal to. Add, and again this should be equal to this. Add, and finally it should also, none of these should be greater than 200. So this should be less than equal to, you can directly write 200 or you can just choose this. click on OK. So these are all my constraint, because ma'am has put named ranges, so it's coming as flow. Otherwise, it will just be the cell references. Now you can do a simple LP and click on solve and OK. So this is the total cost for that. Arc at capacity. So flow equal to B4. B4 is okay. So this is basically saying how many nodes. So here just this is at a capacity, this is at capacity. So it's just doing a count if any of these points are at 200. So this is the thing. This is the minimum cost. I'll just check with what solution ma'am had provided to check if this is fine. I think the red band. Uh, yeah, this one. So 3260. There seems to be some error. I'll just check. So this is being met, no problems here. This is being met, and here it says 38. So this is exceeding 300. Let me check why. Um, this is F8 to F33. This will be this one. Acha, I have not added that. Okay. Add. This should be less than equal to constraint. This. Okay. Now I'll solve again. Okay. So now the answer is 3260, which is matching as per ma'am's answer. Tripathi, you have any questions?
No, no, I do not have any questions. Perfect.
Okay. Okay, guys, thank you. I'll share the Excel sheet as well.